All right, topic 3, inequalities, our favorite. All right, let's look at our first example. It says solve and graph. We have 2p plus 3 is greater than or equal to 9. Remember, let's see, maybe we could write a little key up here to remember, or maybe off to the side up here. Let's see. So we have less than, or like this. This is less than. Or less than or equal to. And then if it goes this way, then it's like greater than or equal to, if it has the line underneath. Okay, cool. So solve and graph 2p plus 3. This is greater than or equal to 9. I want to get that back to blue. Use that one. Great. So here's p. We need to get it by itself, so I'm going to start by doing minus 3 on both sides. All right, if we do that, we still have 2p over here, plus 3 minus 3 are gone. Greater than or equal to 9 minus 3 is 6. All right, and then we got to get p by itself, so we have to divide both sides by 2. 2 divided by 2, p greater than or equal to 6 divided by 2 is 3. Okay, so here we are. P is greater than or equal to 3. This is our answer, but they also wanted us to graph it. So let's look down here at our number line. So we're looking for all the numbers that are bigger than or equal to 3. So let's find 3 on here. Here it is. Okay, so 3 is right here. Since it's greater than or equal to, I'm going to fill it in, because 3 is greater than or equal to 3. It's equal to it. All right, we want the bigger numbers, so we're going to go to the right. Greater than or equal to is to the right. Here we go. We'll just shade in this side. Nice. This is a graph of p is greater than or equal to 3. All the numbers on this side, for instance, here's 4. 4 is bigger than or equal to 3. And 5 is bigger than or equal to 3. So that's our graph of all the numbers that are greater than or equal to 3. All right, solve and graph. So you might remember there's one little trick or thing we have to watch out for when we're doing inequalities that we don't have to worry about with equations. So I'm going to start this one by subtracting 2, because we got to get g by itself. Now I'll have minus 6g, or negative 6g, it's gone, greater than 14 minus 2 is 12. Okay, here's the thing. I want to divide by negative 6, right? But when we divide by a negative, we have to flip the inequality. This also happens when we multiply. Multiply or divide by a negative means we have to flip the inequality. Okay, so here we go. So I'm going to have g, but instead of greater than, now this is going to flip and be, I'm going to make this red so it stands out, less than. 12 divided by negative 6 is negative 2. So our final answer here is g is less than negative 2. We need to graph that down here. Where's negative 2? Oh no, I don't have it on my graph. Here, we'll just change this a little bit, because I make the rules. We'll just relabel these. Let's make this negative 3, negative 2, negative 1, 0, 1. All right, now we're ready to go. Here's negative 2. I'm going to use an open circle because it's just less than, not less than or equal to, and we want the numbers less than negative 2. Numbers less than are on this side. There we go. So this is a graph of all the numbers that are less than negative 2. Okay, here we go. All right, so we also had like and or inequalities. So this is an example of an and inequality. They wrote it like the sandwich. I think of like and ones are like sandwich ones. They can write it like that. And then this one over here is an example of an or inequality. The or ones get the outsides, so they're going to look like this. And ones, sandwich, are going to look like this. So you're going to get just the inside parts. Okay, 5 is less than x plus 3 less than 10. Okay, let's see what we can do with this. Here's x. We're trying to get it by itself. I have a plus 3, so I'm going to get rid of it by doing a minus 3. But we're really doing two problems at once here. So I have to subtract 3 from this 10 and subtract 3 from this 5, because they're on different sides of the inequalities. So now we have 5 minus 3 over here, that's 2, is less than, just this x, is less than 10 minus 3 is 7. All right. Here it is. How does that look on a graph? That's the question. So let's see, let's find 2 and 7. Here's 2, here's 7. This is an and problem, so our x is in the middle. We're going to get all the numbers in the middle. Okay, and then we're just going to leave them as open circles because these are both just less thans, not less than or equal to. So we'll leave them as open circles. So that is the graph of numbers that are bigger than 2 but less than 7. Nice. Okay, so that's sandwich ones. All right, we also have or ones. So for or ones, we just kind of have to solve them separately, and we're going to get the outsides. So on this one, we're going to do minus 8, minus 8. So we just have v is less than 3 minus 8 is negative 5. So that's one side of our answer. On the other side, oh, careful on this. Look, we want to divide by negative 8. But we're dividing by a negative, so we have to flip the inequality. Okay, so we end up with v is greater than. Negative 40 divided by negative 8 is just 5. Okay, so we have two parts to our answer. We are allowed to have numbers that are less than negative 5 and greater than 5. So negative 5 is right here. We want numbers less than that, so we're going to go this way. There's numbers less than negative 5. Numbers bigger than 5, here's 5 right in between 4 and 6, is this way. So that's our answer. Oars, someone told me it's like oars look like the oars of a boat, so they go out to the sides, like the handles to a boat, or the, paddles to a boat, like the oars. So there's and versus oars. And don't forget to flip your inequality if you multiply or divide by a negative. That's everything.